Hi there and welcome back to Triplicate, home of interesting electronics. And today, as you've probably guessed by now, we're going to do some more work on the Mean Green Synthesizer, hardware synthesizer. So, firstly the hardware. As you can see, I've taken the front panel off the box and printed out the front panel layout full sized, and I think it'll be okay at that. Now that is glass, so I have purchased some acrylic plexiglass is the brand, because it's a lot easier to drill holes in that than it is in glass. I've also started work on mounting the front panel components. So here we have an offcut of the plexiglass with the oscillator components marked in. You see the switch there, which is just a micro switch. Focus on that, just a micro switch poking, not a micro switch, a tack switch poking through the hole, 2 green LEDs and 5 knobs, which I discover they're all at minimum and they're all pointing the wrong way, but this does not matter for our application. And to get that, I cut out the boards and scanned the surface of the Veriboard. This is just Veriboard or stripboard, and then laid them out, the scans out in a drawing. And you probably can't see there are black dots where the holes should go, and then I copied that and just left with the black dots, taped that down on the surface of the perspex and used it to drill, and yes, they all ended up lining up quite nicely. So I just have to, well, put those components in there and get on and do all the others, and we're good to go. I shall probably do that all off camera because it's not very exciting watching me drill holes. So I have also mounted the Nucleo on a nice big piece of strip board, onto which hopefully all the other components will fit. And I thought this video I was going to start looking at the display. Now I was going to use this display, which plugs if you get it the right way around. Anyway, it plugs in these connectors here, which are set up for Arduino shields. This is an Arduino display intended for an Arduino, but when I started looking into it, the driver chip used on here, plenty of people have got them working for the Arduino, but when it comes to the STM32 on here, only managed to find people who had loads of trouble. I suspect this is bus timing issues, because this is a sight faster than an Arduino 80 mega processor. However, I don't want to spend a lot of time just trying to get a display working, and I don't really need a graphics display, it's just that I bought it. So this is now going for some other Arduino project away. So instead I bought, for the princely sum of £5, a 4 lines by 20 character display, because we only want to display the value of this is whatever, don't need any fancy graphics. So that's what we're going to use. Set princely sum of £5, but it says on it, oh god, if you can't see that, it says on the 2014-06, so it's sort of nearly 6 years old. It's actually been sitting on a shelf somewhere, which is probably why they were selling them cheap. So that's the next task, is to connect that up and try and get it working. Okay, so we're trying to connect up the display first up so that while we do debugging we can actually put some useful information out to look at. This chip and the Nucleo do have a built-in debugger, but I find it's always easier just to be able to put a line of text on a screen or a display. However, the display takes 7 data lines and 3 control lines, and we can't just slap them on here anywhere, because we might find that other peripherals need to take the pins that we've assigned, and then we'd be in trouble. We'd have to rewire the pins. So before we can connect the display up, we need to just check where the other peripherals we're going to use are going. So we have, apart from the display and the knobs and the switches and the LEDs, we have a MIDI interface, which is a serial input and output, and we have an I2S interface for the audio output board, which we'll come to anon. So I have done a little investigation and checking what pins are available to what, and I reckon that this is how we're going to wire it up. So here we've just got the unit, here, so that's the display. Here we've got the function within that unit, so datas and then 3 control lines, and here we've got what the pin on the STM32 that I anticipate we're going to use. So for now I've done the display, which is what we want, and the audio and the MIDI, because these are the ones that we might have to work around. Okay, so let's make a start on adding peripherals to our setup. So this here, we're in CubeMX, which is this clever setup program. So I am going to add the I2S, and I've decided I'm going to use I2S3. So back into here comes the clever bits. I2S3. Okay, and I'm going to set that to half duplex master, and for now I'm not going to bother with any of the parameters. We can change them later. So I'm just going to get rid of a bit of that. So now we can see we have this pin, this pin, and this pin assigned to the I2S. Right, so going back to my spreadsheet, you see here I've asked for UART 1 for the MIDI, which is just a serial interface, uses a UART. So we go back to here, we look in connectivity, and we ask for UART1, and we want it asynchronous, and we go over here and it's PA9 and PA10. So now we can put the display ones in. So we look back at the spreadsheet. So we want PC2 to PC9, they're the data lines, so let's do them. PC2 okay, so yep, didn't read the list carefully enough. Missed the obvious one down here. So GPIO output. Now if we look down here, those are, that one for instance they've managed to name, so I don't know how I do that. Oh, enter user label. Disp D0. Okay, well I shall go through and do all those for the display and bring you back. Okay, so here we are done. Those to display, those to a display, and those to a display. So I shall save it and start wiring up, and I guess bring you back when there's something to show you. Okay, it's been a couple of days, and before we get into hardware I realised, showed you the picture of the front panel and then said I'd change the display, and of course the picture had the old display on, so took a bit of time and yeah, updated the picture so it's got the new display on, and still not happy at having the value pot there. Might put it up there and move the display up. Anyway, that's for another day. So I have here the wired up display with the reflecting light, and it's not pretty, and goodness knows what it'll be like at high frequency, but we shall cross that bridge when we come to it. So I've checked for continuity and short circuits everywhere, but I haven't powered it up, and I thought I'd do that now. And the question is, if I power it up and something goes foot, embarrassingly, because I made a huge blunder, would I publish the video of it? As I sit here now, I'm not quite sure. However, I've got it powered via a little USB breakout thingy to the power supply, the bench power supply, and I'm going to start it at 5 volts and very gradually increase the current. And here I'm monitoring the 3V3, and if the 3V3 comes up alright, my guess is there's nothing too badly wrong, and I've been monitoring it on my trusty multimeter. So without further ado, I shall put the camera in the stand and fingers crossed. Alright, so On with the multimeter. I'm going to pull the plug out of here firstly. On with the power supply. Just check that's sitting at 5 volts. Yep. So current back down. Okay, off with the power supply. Plug this back in. On with the power supply again, and shall we give it some current? Very gently. Oh! Ah! So, something's happening with the flashing LED. That's the communications. It's trying to communicate with the computer, which it won't because I'm just powering it. Let's give it a bit more. Oh. Okay. That's the backlight starting, so alright. We have flashing LEDs, which means the Nucleo is running. We have 3V3 there. It's only drawing about 100 milliamps. The current limit's off. And the display is doing something display-like. Yippee! So, right, you can't see probably because of the wire in the way. In the back here is the contrast pot for the display. Yes, I know we could have driven it from the processor and had it in a menu, etc, etc, but I can't be bothered. Right, where's my little preset? There's my little preset. You can catch it. Let's see what happens if I twiddle this twiddler. Ah. Right, well for now I'm going to make the assumption that it's booted up in every segment on. Oh no, hang on. There are 4 lines, 1, 2, 3, 4, and 2 are all on and 2 are all off, so that looks like a decent setting for the contrast. So, I think it's time we plugged it into the computer and had a look at some code and see if we can get something to display on the display. Fun, fun, fun. Okay, so we have our Cube MX project here that we set up to drive the display and the other bits and pieces, which we're not going to look at today. So now we need to generate our code, for which we need to be in the project manager. Okay. Okay. It was that tool chain we need. Settings. Use latest version. Right. So that's the project setup. We just needed to set the toolchain and IDE. Advanced settings. Don't know. Nope. going to leave the code settings, the code generator settings, should I say, as they should be, and we are going to generate code. Now this code should appear, oh it is, this code should appear in this folder, should I say, and there's a shall we open project? Allow access. Yes. Come on. Right, so I am going to create a new workspace, switch workspace to other, browse, triplicate, Mean Green software. And I am going to call this MG workspace. So I am. Is that going to happen? It's now going to start it up again. It does when you change workspace. And oh, so it's automatically imported in my project. That's good. Okay, so I am now going to write some code in that project to hopefully do something on the display and bring you back when it's time to try it. So we have some code which I don't intend to go in too much detail. So we have an LCD out function which sends a byte to the out to the LCD, an LCD in function which gets a byte from the LCD, and an LCD write char which sends the char out and waits for the LCD to finish doing what it does. This while line just gets the status from the LCD and polls the busy bit, which is bit 7. And just because this is all new to me, just sort of my thoughts while I was figuring it out, we have this HAL GPIO write pin function, and we've used the toggle one just to flash an LED, but then I soon found these functions are all very well, but they don't give you the functionality you want. So here, to change the direction of the port and read the whole port and write to the whole port, as you can see, I've had to resort to writing directly to the registers in time-honoured fashion. Okay, I know it compiles, but I haven't run it. So, shall we see what it does? Oh, I'll just go into the main C. Can we find the bit of code? Here we go. So every 50 milliseconds we're toggling the built-in LED just to confirm it's still alive, and we've got a char counter which counts from 33 to 122 and sends that particular character out to the display. The display, I believe, auto increments. I don't know, we're going to find out. So it should just start putting a sequence of characters to the display. And if it does, I shall be amazed. Right, so let's do it. Run menu. Debug as that one. It should get that far and hit start. Okay, and the LED is flashing and the display is doing absolutely nothing. So I am gonna set up the scope and start looking at some of the lines going to the display and see what I am doing wrong, and I shall probably just bring you back to show you the results. Okay, so 2 days later and I finally got it working. Haven't videoed any of the processing because be a lot of video of me looking at it and going which is not too exciting to watch. So here, as you can see, it's, there we go, on that line, just drawing successively higher ASCII number characters, and if we press reset it'll start at the beginning and do line 1, line 3, line 2, line 4, but we can get around that. Well, fair enough, half of the course, since both the display and the processor are new to me. It's not surprising, it's taken quite a bit of time. Part of the problem is 2 of the port lines coming out of the STM32 to the display stopped working, and this, well, just in case this was to do with me getting the bus timing wrong and the display and the processor trying to write to the lines at the same time, I put 1K 5 resistors. I don't know whether you can see them, but for the cabling, so even if that was driving the line low and that was driving it high, it wouldn't potentially blow it up. But I don't think that was the problem. I think the problem was actually one of static discharge, because all these have pins sticking up at the top and down at the bottom, and they will go straight into the lines on this with no sort of protection. So I suspect I've frapped a couple. So I need to take better anti-static precautions in here, better than a sheet of paper anyway. So I had to, before I had all these data lines were eight consecutive lines on one of the ports in the micro, so I could just use a shift to turn the data value into the relevant port value, but I had to change 2 of the lines and now they're not, so I have to go for all this. Where are we? These clunky routines to turn the port value into a data value. Other choice things I did was I initially had the LCD init routine up here before the GPIO init routine, so it was trying to drive lines to the display that weren't doing anything. I also wasn't initializing the LCD properly. Specifically, I wasn't actually turning it on, so it's not surprising it didn't do anything. And it was not until I actually looked on the datasheet for this chip, which gives this helpful initialization sequence, that I got the initialization wrong. Oh, and I was working from the datasheet from the Hitachi driver chip, and there are, well, I found one very slight difference which nevertheless would have stopped it working. So always read the datasheet, and always read the correct datasheet for the chip you're using. So I think I'll call it time on this video. I will go away and write some routines to actually put text on the display on the line you want, and clear the display and do all these bits and pieces, just to try and move the thing along a little. So if you're finding this interesting, please subscribe, and I promise it will get more interesting. Leave a comment if you've got anything to say. Thumbs up would be nice, and until next time, it's goodbye from Triplicate, home of interesting electronics. Goodbye.